All right, today is January the 8th, Friday, and we have Google Meets today. This is for physical science, second block. Just to a reminder, you're going to go into first, you're going to go into your Canvas, and this is what you're going to do every day. You are going to go to today's activities, and you're going to scroll down to today's date, and you're going to complete the attendance. With the attendance, you're going to need to complete your notes first or use the PowerPoint to answer these questions. So remember, you're going to click on Submit Assignment. You're going to number 1 and type your answer. You're going to do 2, type your answer. Don't just put the word answer. You need to type your answer and all the way through number 5. When you get finished and you've answered all of them, you click Submit here and it will submit. And notice how it gave me this confetti here. It lets me know it's submitted. It also says resubmit at the top. Then you're going to go back to home. And or you could go to modules and then you're going to do the next thing, which we're going to get to in just a minute. I'm going to go ahead and open it up. This is our notes for today. So you're going to, before we do that, yesterday we talked a little bit here, and throughout my classes, we've talked about asking in a polite manner, so respectful actions, again, that might fall under there. Here we're looking at how to enter the classroom if we're here face-to-face, what to do if you don't have any supplies, and how to ask to leave the classroom. We are wanting you to use hand sanitizer as you enter the classroom, and there's a hand sanitizer dispenser by each door. And then the main thing is coming prepared. And what that means right now is if you're face-to-face, you are bringing your pencil pouch that we gave you. And so we'll be looking for those and having them ready for when we're returning face-to-face. That pencil pouch needs to go with you to every class. You also need your Chromebook. You've got to remember to bring it from home so that you can have your Chromebook, and also bring your charger so that you can charge if you did not charge it at home. Make sure you've gone to the restroom and had a water break between classes. What do you do if you don't have supplies? First, you need to think about where you've done it, and I don't necessarily want to put that there, where you've left them. But if you've left them in another room, you need to request permission politely to go get them. And don't take a long time. Don't interrupt that class by talking to other students. You just go and you get your materials. If you can't find them, you need to ask to borrow some for that day. I couldn't think of anything else to go there. If you think of something, make sure you send it to me in an email. How do you ask to leave the classroom? You're going to try not to have to leave the classroom during class time, especially this year when we only have about an hour. But if you do need to leave to go to the restroom, or if it's an emergency of some point, you need to make sure you're asking at an appropriate time. So not in the middle of a lecture. You need to wait till we're on some independent work. Would be the best time. Now, if it's an absolute emergency, we can work with that, but appropriate time for most of that time. We've got one or two more of those that we're going to do next week, and then I'll show you the final, or share with you the final one. All right, so we're going to be looking here. Well, fiddledy. Okay. Leave student view. What do you mean page not found? Oh, I'm in the wrong thing. Now I know. Okay, I need to close that one out. All right, so when you open up your notes, these were actually due yesterday. Don't worry about it showing up late or whatever. This one I won't take points or anything off because we just didn't get to it yesterday. So I have vocabulary at the beginning of the slides. These vocabularies would be good to review before we take a quiz. You're going to, down here, fill in. And to fill in, you're going to get a text box. And you're going to click where the text box is. And it would be nice if you would use a different color. Right now, that one's set for like 30. You may want to bring it down to 14 or 12. And as we go along, you're going to type and fill in the missing. When you're finished, you're going to click on Submit here, and it will submit it. So you can open this in a new tab as I talk through it, or you can go through the PowerPoint and fill it in as you go. So scientific method, we've got science. So hopefully this is a review. Many of you have sat through science, is definitely in middle school and through some in your high school. Felt a sneeze coming on. Science is a way that we study the world through observations and investigations. So making observations, that's how we gather information. It's going to be based on our 5 senses. What do we see? How does it feel? How does, may or may not use taste, depending on the situation. What do we hear? So your 5 senses. So this morning, when we all woke up, if we had listened to the news, you would have been expecting some snow on the ground, but our ground was wet. So that was an observation. You may have seen rain or not. Your inference is sort of a guess about that observation. And so if you hadn't seen it rain and it wasn't raining, you may have said it rained. If this was on your front porch and the ground was not wet, then maybe someone spilled something. So you're making an inference, a guess about what caused that observation. So here you have a picture, and an observation would be things like there's a computer, it's a laptop, maybe a Chromebook. There's a baby. The baby has blue eyes. The baby has a striped shirt. The baby is wearing gray pants, white socks, touching the computer. Those are all observations. Inferences would be that the baby is a boy. At this age, we cannot tell. We could, probably the inference could be that this is mom was working and she got up, and so baby's touching the computer. Or maybe mom left the computer and baby is coming to, and open the computer. Those would be inferences. We don't know how the computer got open, and we don't know, at what point the baby got there. So those would be inferences. So you've got to know the difference between those two. We have laws, and on your note sheet, I believe this section, if you look down, just like with observation and inference, they're in 2 little columns here. So scientific laws are descriptions of how things happen in nature. This would be like Newton's laws, which we'll actually study second 9 weeks. You've got a theory is an explanation. So think of law as a description. A theory is explaining, is trying to give you the why something has happened. So our evolutionary theory in biology is explaining why species have changed over time. So laws cannot become theories and vice versa. All theories start off as hypotheses until they have enough evidence to back them up, and then they will become fact. Let me see. Trying to get it to go to the next slide. There we go. As we keep going, we have the scientific method. This is how scientists actually go through and investigate something. It usually starts with an observation. I like to add observation in there because that observation leads to a question. You're going to do some research to gather some background information. You're going to form a hypothesis. This is what you think based on your background information and what you know. What is your inference? It's what you think is going to happen. Then you're going to set up an experiment to test the hypothesis, and you're going to analyze your data and draw conclusions. So, asking a question, this is going to be based on observations we make. So, when you make an observation, you're going to ask a question, and this is how we're going to define our purpose for conducting an investigation. So, research, we're going to gather background information. So, you're going to see what other people have come up with, what others have studied, what other experiments have been done. And if we were writing this up, this is what would go in your introduction to your lab report. And you want to make sure you're using trustworthy resources. You may start out using something like Wikipedia for just a general, but you want to find some scientific articles or sites that end in .edu, .org that have more reliable, trustworthy information than Wikipedia. And then and so anything .gov, .edu, .org are your best. Then you're going to take that information and you want your prediction, your guess to be testable. So it's going to attempt to answer that question that you started out with. And usually it's going to have a cause and effect relationship. So it's going to be an if, the independent variable, we'll talk about that in a minute, if the cause, then the effect, which is your dependent variable, because, and you give a reason. That's kind of the format that we use for independent variable or making a hypothesis. So independent variable, your cause, dependent variables, your effect, and then you want to have a reason that that cause is going to result in that effect. So the independent variable, and this will help you on your attendance, this is what's being purposely changed. It's what's being tested. It is the cause. So this is what you would write for that question. Dependent variable, this is what's being measured. It is the data you're collecting. It is the response. It is the effect. So I always notice that many runners drink Gatorade. So that's an observation. I want to know if Gatorade, that is the independent variable, makes them run faster. I can measure running, or so faster is my dependent variable. Speed is my dependent variable. So that would be, I just did that for you. Independent variable is going to be the Gatorade. Dependent variable is going to be how fast they run. So a hypothesis would be if runners drink Gatorade, then they will run faster. So a lot of times I don't do the because and we stop with just after the dependent variable, but sometimes you will see the because there and a reason. All right, then you're going to set up an experiment. You're going to list all your materials. If you're writing this up, you would have to have a step-by-step procedure. A lot of times this is given to you when we do labs in class. It should always have a control group. This is a normal group that's used for comparison. This would be like the placebo group, like all the people who joined testing groups for vaccines for the coronavirus back at the end of last year. So they didn't know, but some of them, when they sign up, they get randomly put in a group. Some were put in a control group, and then some were put in the experimental group. The control group did not get a vaccine. They got a shot, but it didn't contain the vaccine. It was a placebo. The experimental group got a shot, and it was the vaccine. So this is the group that is actually being tested. It's going to have the independent variable. Constants, these are factors that do not change. They're kept the same. Like you'd want the same age of people getting the vaccine or the same age range in there. You'd want them to have similar health backgrounds and things like that. So constants. Um, so for the Gatorade experiment, you would have a group that would drink maybe water. Then you'd have a group that would drink Gatorade. Things that you would keep the same is you would maybe want the either all males, all females. You would want them to be in the same age range. You would want them to have the same training and so forth. You wouldn't want a non-runner to be running against a marathon runner because obviously the marathon runner will have the faster speed. So you want to keep things similar in those groups. You're going to analyze the data. You're going to organize the results. Usually you collect this in a data table and then you put it in a graph. Quantitative is numbers. Qualitative is descriptive. So in this picture, quantitative would be one dog, one blanket. Qualitative, I mean, that's, and then qualitative would be the dog is wrapped in the blanket. So you're using words. And then you're going to use graphs. So here's graphs. You've got line graphs. So usually you're going to have two pieces of quantitative data. So you're going to see growth over time. Usually time is going to be involved. Bar graph is qualitative and quantitative. So you've got some type of number with a category, which is descriptive. So number of students of favorite classes, or you have a pie or circle graph, which has percentages. So the percent of students who got a certain grade on a particular test. And then you're going to analyze that data. So when you do graphs, they must have a title. You must label the X and Y axis. You must include units. You must have it evenly spaced out. You must have a key if you need to have, if you have more than one line there. So there's examples of each of those. In a written analysis, you're doing so if we're writing this up in a lab report, you do an overview of the variables. You would have an explanation of what the data shows, referring to the graphs. You would give a reason. You would infer why you got the results. And then you would think about any possible mistakes and discuss those. So usually you want to say, were there at least 3 things that could have either not been held constant, could have done something, how would you have messed up, or what could you do to prevent it? Usually you want to try to address 3 things. And then you complete, after you've completed the lab, you draw conclusions and a clear statement of if the lab supports the hypothesis or not. So you're not going to say proven or disproven, correct or incorrect. You're going to say support or does not support. And you always put what you've learned and try to relate it to something in the real world. So that is just a review of scientific method. So when you have filled in these notes, you're going to click submit up here at the top. One thing that might happen when you first open this, you may get something that says authorize your Google Drive. Make sure you click on that and follow the directions so this would open. If you go back to modules, you will see there's one other thing for today. If you scroll down to today, and it's there's an ed or 2 things. There's an ed puzzle that goes over scientific method. So I really need you to make sure that this works. If this does not work for you, you need to let me know. It's not going to show up here because I am in student view. But you should have a video that pops up. And if you haven't done never had this happen before. You shouldn't have to log in. So it should, let me just do it this way. You shouldn't have to log in. It should automatically have the video there. Oh. Okay, then. I will need to fix this. You'll have a video. And then you've got a, I'll go here and re-choose this. And puzzle. Huh. That sounds good. And we'll do. Of course, they don't have the one that I want. Well, I'll do that for right now. Create class. Never had it do this before. This is interesting. Um, well, I think it is. I think it's this one. I'm not sure. It's really weird. Assign. Okay. If I did, oh, that says 10, but it should be. Okay, well, I may change that, but hopefully that will be the right one. So you're going to have this video, and for you, it's going to pop up, and it'll be play, and there'll be questions that you answer. Um, so we will see how that works. Part of this is I'm using it from last semester, and I'm not sure what's going on there. All right, so the other thing or the last thing that you're going to do is right here, you're going to practice, and it's going to be practice identifying an independent variable, dependent variable, and from your notes. And so you're going to want to read here. And so Maggie loves fresh brownies. Her grandmother told her that if she places a piece of bread, let me see if I can, in a storage container with the brownies will stay fresh and moist longer. She decides to test the idea. She bakes a batch of brownies. She places 6 brownies. So we've got brownies. We've got individual Tupperware containers. So the container is the same. Each brownie is the same size, placed in the same location. She adds a piece of bread to 3 of them and leaves the other 3 alone. All right. So, and for 3 weeks, she measures the moisture of the brownies and records her results. All right. So, if we were going to do this one together, you would have independent variable is piece of bread. Dependent variable is amount of moisture, because that's what she's measuring. Hypothesis is, it's right here, the brownies, if a piece of bread is in the storage container, if a piece of bread is in the container with the brownies, then they will stay moist. So that would be your hypothesis. Your control group is the one with no bread. Experimental group contains bread. Constants, you've got the same type of container, same size, and same location. So look for same. So that is an example of how you would do that. So I know this was kind of long here, but this is today's less. I was going to try to fix that misspelling, but oh well. So that is how you do this. When you get done, you will submit. So you automatically will get 6 points because I have filled in what you have here. You can type it in from the video. I'm going to go and erase this. And so you're going to, when you are finished with each of these, you will submit, and then you are finished. So you have sort of 3 things: the notes, the video, and this. If you have any questions, please email me.